All right, so today we are going to talk about the law of conservation of energy. And up to this point, we have talked about the different forms of energy: thermal energy, chemical energy, mechanical energy. Um, we've talked about the different states of energy: kinetic energy and potential energy. And today we're going to talk about how when you change from one kind of energy into another, um, none of that energy is lost. And that's stated in what we call the law of conservation of energy. And that states that energy cannot be created or destroyed, only changed in form. So when I take an object and I drop it off a cliff, it starts out with a whole bunch of potential energy. As it speeds up, it becomes kinetic energy, but the total amount of energy between potential and kinetic never goes away. And we call that sum of the kinetic and the potential energy the mechanical energy. This does not include the thermal energy that's included in the object. It does not include the nuclear energy stored in the nuclei of the atoms of the object. It does not include the chemical energy stored in the bonds of the object or liquid or substance. So I'll just run through a couple examples. So let's think like you're going to the park and you're going to go on the swing set. All right, as you swing, you go back and forth, and that's just an example of what we would call a pendulum. Now, at the top of the swing, when you're all the way back, you stop just for an instant while you're changing directions. And at that moment, when you're stopped, you have no kinetic energy. Okay, and if you have no kinetic energy, it means that all of your energy must be potential energy. Well, guess what? You're at your highest point, which is where you have the most potential energy. Now, as that swing starts to swing down, oops, as the swing starts to go down, the height changes. The height gets lower, and so the potential energy decreases. But that decrease in potential energy is matched by the increase in kinetic energy. And so if something's gaining kinetic energy, what is it gaining? It's gaining more speed. So it's going to go faster and faster and faster, lower and lower and lower. So the mechanical energy is mostly made up of kinetic energy right now. Now it gets to the bottom of that swing, it goes past the fastest point, and then it starts going up again. Increasing potential energy because height is increasing, and things slow down as they move upward. So the increase in potential energy is matched by the loss of kinetic energy. Now, this is an example of something I'm going to actually show you more in detail mathematically in a couple days, but for now I just want to kind of qualitatively look at this. This represents a roller coaster or one of those tracks you would make for, say, a Hot Wheels car, but we've got some object up here at a height, and in this case it's 4 meters. Now, at the moment, it has no kinetic energy. It has no speed, no velocity, so KE is 0. But it is at a height, and that means that it has potential energy. So whatever potential energy it has, plus the 0 kinetic energy, those two things together make the mechanical energy. That's the total energy that this object has, and that is not going to change for any of these situations, 1, 2, 3, or 4. Now, as this object falls, it loses height, but it gains speed, and it's going to get faster and faster and faster, and it's going to come around, and now we look at situation number 2. Now it's at a position that is only 3 meters high. Before it was 4 meters high. So it has lost some height, meaning it has lost some potential energy, but it is moving now. It's got some speed. Whoops. It's got some speed. And that means that whatever potential energy it has that is less than over here, that is gained right here because the sum has to still equal the same mechanical energy. Now this object is going to come down. It's going to get faster and faster and faster and lower and lower and lower until it gets to the very bottom. And at that point, it has no potential energy because the height is 0. But it's going as fast as it can. All of the energy is kinetic. None of it is potential here. And so we still have the same ME. And then it starts rolling back up this hill. It's getting higher and higher, gaining some height, but losing some speed. And again, the PE will increase, the KE will decrease, but the sum remains the same. All right, one more Example I would give you here is when you throw a ball up in the air. So when you throw a ball up in the air, and let's say we're throwing it straight up in the air, the fastest that ball is ever going to go is right when it leaves your hand. Okay, you throw it. Once it leaves your hand, you're not pushing on it anymore. And at that point, the only force acting on it is gravity, which is trying to pull it back down. It can't pull it down immediately. It has to start by slowing it down. So it's the fastest at the beginning. The height is almost nothing. And the kinetic energy, therefore, is at its greatest point. The potential energy is at its lowest. Now, as the ball goes up, it slows down. The kinetic energy, therefore, is decreasing, but the height is increasing, which means the potential energy is increasing. So less KE means more PE because the total between them has to remain the same. At the very top, when you throw something up in the air, its velocity is 0 because it's changing direction, which means it has no kinetic energy, which means that all of the energy has now been transferred into potential energy, and it's going to start falling immediately. And so as it falls, that height starts to decrease, so the potential energy decreases as well, which is matched by the increase in kinetic energy and the increase in speed.